Hello. In this video series, we will take up queuing models for our discussion. Here I have one of the questions in queuing models asked in 2022 examination of Bangalore University. The question is displayed here. I will read the question. At a veterinary clinic, there is a single vet vaccinating pups. Every 5 minutes, 20 pups arrive. The vet can vaccinate 15 pups in minutes. Please take that as 15 pups in 3 minutes. Assuming the arrival rate of pups follows the Poisson distribution and the vaccination time follows the exponential distribution. Determine the following. A. The average number of pups in queue. B. Average time a pup spends in the system. C. Average time a pup waits before vaccination. So please read the problem 2 to 3 times so that you will understand what is given in the problem and what is being asked in the problem. At least 3 times you must read. With this background, we will try to understand some theoretical concepts and then we can move on to solve the problem. We can assume this is the given problem. The puppies are in the queue and one of the puppy is being vaccinated. This is the customer input is the arrival rate denoted by lambda. Once the service gets over, the customers leave the system and it is denoted by mu, that is the service rate, the rate at which the customers are being serviced. Here this red border, this indicates the service facility where the customer is being serviced. In our case, it is the puppies being vaccinated. Then we have this black border area where 2 puppies are waiting to be vaccinated. This is called the queue or the waiting line. You can see a blue box. The entire waiting line and the service facility is called as service system. In this system, we have n number of customers arriving into the system, then waiting in the waiting line, get the service facility at a particular rate and then leaves the system. Here we have this traffic intensity or the utility factor. It is the proportion of time the system is being busy, which is given by rho is equal to lambda by mu. With this background, we can move back to the problem. So here the arrival rate is given. The arrival rate is every 5 minutes 20 pups are arriving and the service rate is given. For every 3 minutes 15 pups are being vaccinated. I clearly understood that there is some information missing. I do not know exactly what is that number, but for discussion sake, I have kept that number as 3. In your case, you can increase that number and see what answers you are getting. So the arrival rate lambda is given, then the service rate mu is given. We are to find the average number of pups in the queue, average time a pup spends in the system, the average time a pup waits in the queue. Okay, given arrival rate lambda is equal to 20 puppies every 5 minutes, which can be written as 20 by 5 and the value is 4. Service rate mu is given as 15 puppies every 3 minutes. We can write it as 15 by 3, which is 5. And now we have to answer the following questions. A is average number of pups in the queue, which is the length of the queue. B, average time a pup spends in the system, which is waiting time in the system. Then C is average time a pup spends in the queue, which is waiting time in the queue. So quickly we will refresh some of the formulas which we have discussed in the class. In our case, we need the length of the queue. The length of the queue is given by lambda by mu multiplied by lambda by mu minus lambda. Using the utility factor or the traffic intensity, this formula can be written as rho into rho by 1 minus rho. We need this to solve the A subdivision. Then we have been asked to identify the waiting time in the system, which is given by the notation Ws, and the formula is 1 by mu minus lambda. If we know the waiting time in the system, then we can use this particular formula. Then the C subdivision is waiting time in the queue, which is given by WQ. So already we might have calculated this LQ, length of the queue for A subdivision. If you know the length of the queue value, then directly we can substitute LQ, and lambda value is also known. We can calculate directly using this formula. If we have not calculated LQ, that is length of the queue, then we must use this particular formula, lambda by mu into 1 by mu minus lambda. We will go into the problem. First subdivision, length of the queue. So the average length of the queue, LQ, is given by lambda by mu into lambda by mu minus lambda. Lambda is 4, mu is 5. So substituting we have 4 by 5, and here we have 4 by 5 minus 4. Again, when we solve, it is 4 by 5, and this is 4 by 1. Finally, 4 into 4 is 16. 16 by 5 is 3.2. So approximately 3 puppies will wait in the queue, given the arrival rate and service rate. We will move on to the B subdivision, waiting time in the system. The waiting time in the system, Ws, is given by 1 by mu minus lambda. Mu we already know, 5. Lambda is 4. 5 minus 4 is 1. 1 by 1 is 1. So a puppy which is entering into the system has to wait for 1 minute, and then it can leave the system. The waiting time in the system is waiting time in the queue plus the service time, which is 1 minute. We can move on to the third subdivision, which is C, waiting time in the queue. Waiting time in the queue can be solved using either this formula, or we already know we have calculated the length of the queue, which is 3.2 puppies. If you want to take the rounded off figure, then it will be 3 puppies. So waiting time in the queue, WQ, is equal to 3 by 2 by 4, or otherwise 3 by 4. So in this case we get 0.8 minutes. So before being vaccinated, each puppy should wait for 0.8 minutes, which is less than 1 minute. So we have answered all the 3 questions, 3 subdivisions asked in the question. Thank you.